Okay, so we are going to have a little bit of a review of interior and exterior angles. Now, this is a topic that you've all looked at over your home learning on Dr. Frost. So this first page really should be quite familiar to you, and it just outlines some of those key formulas that you're going to need. So the first one, obviously, we look at being able to find the sum of interior angles in a polygon. Now, the way in which we do that is by dividing or splitting the polygon up into triangles. We know the sum of angles in a triangle is 180 degrees, and we use that fact then to be able to find the interior angles of other polygons. So that formula there that says 180 degrees times n minus 2, that should be familiar to you. And remember that n is the number of sides. So for a 5-sided shape, we would do 180 times, and then in brackets, 5 minus 2. And we should therefore get an answer of 540 degrees. We should also know the link, moving on to the diagram at the bottom of the page, we should also know the link between an interior and exterior angle. So we should know that an interior plus an exterior angle is 180 degrees. Now, moving on specifically to regular polygons, and a regular polygon is where all the angles are equal in size and all the lengths of the sides are equal in size. So if we want to find an exterior angle, then we can simply do 360 divided by n. And the reason that we can do that is because we should know that the sum of exterior angles is 360 degrees. Similarly, or using that same fact, we can also work out the number of sides on a regular polygon. And again, we use that 360 degrees and we divide it by the external angle. So that, as I said, should be quite a recap for you, but it's there just for reference if you need it. So when I've looked at the topic test that you did on Dr. Frost, the questions that were answered the least well would be questions 6, 7 and 8. So I'm going to go through those questions so that you can see how we would actually answer those questions. So here you can see we've got a regular polygon, and it says determine the angle as marked in the diagram. Now, the first thing that we would need to do is to find the sum of interior angles. So remember, for us to do that, we are going to do 180 multiplied by the number of sides, so in this case 5, minus 2. So we're going to do 180 times 3, and we get an answer of 540 degrees. Now, if I wanted to find an individual angle, for example, those that I've marked there in red, then I should be able to do 540 degrees divided by 5 and get an answer of 108 degrees. I can do that because it's a regular pentagon. Okay, so I now know that that angle there is 108 degrees. What I'm now going to do is see if I can actually find, okay, that question mark angle labelled there. So I'm just going to change my pen colour so that I can label it more. So we should now recognise that here we have got an isosceles triangle. And the reason we know that is because the sides of our regular pentagon are equal in length. So with any isosceles triangle, we should also be aware that our base angles, so that angle that I've coloured in green there, and that angle are equal in size. So I'm going to use this fact that I know angles in a triangle sum to 180 degrees, and I'm going to minus that angle that I've labelled 108, so angle ABC. So I'm going to take away 108, and that should leave me with an angle of 72 degrees. Now that 72 degrees would represent this angle and that angle together. So simply now I've got to do 72 divided by 2, and I've got an overall answer of 36 degrees. Okay, moving on to question 7. Well, actually, I'm going to go to question 8 first of all. It's a slightly easier question. Okay, so question 8 is a regular octagon, and we've got two identical regular pentagons. Work out the sides of angle marked X. Okay, so first things first, I've got an octagon. So let's find out what angles in an octagon add up to. So I'm going to do 180 times 8 minus 2. So I'm going to do 6 times 180, which should give me an answer of 1080 degrees. Now then, that tells me what all the angles in that octagon add up to, but I specifically want to know what one individual one. So I'm now going to do 1080 divided by 8 because it's an octagon, and I'm going to get an answer of 135 degrees. So I'm going to label that there on the diagram in green. So 135 degrees. So that also means that that angle there that I've just labelled in green is 135, and that angle there is 135. Okay, so I'll just label one of them. We'll just get rid of that marking for now. Okay, the next thing then, we know from question 6 that we've just previously done that our sum of angles in a pentagon is 540. So in a pentagon, we know that the sum of angles is 540 degrees. And to work out one individual angle, so I'm going to work out that angle there that I've labelled on the diagram, so angle PFQ, I'm going to do 540 divided by 5, which again we should recognise from question 6, and we get 108 degrees. We'll just label that angle PFQ. Okay, so I know that angle, if I go back to my green, I know that angle PFE, so PFE, which is that angle there, so PFE is 135, and PFQ is 108. So for me to be able to work out angle QFE, so QFE, I'm simply going to do 135 take away 108. So 135 take away 108, and that should leave me there with 27 degrees. So I'm just going to remove some of those annotations so that we can see now where we've got, and I can label that angle QFE for you. So QFE is that small angle there. Okay, so I now know then that QFE is also equal to angle QEF because it tells me that I have got two regular pentagons. So I know that that length and that length are equal. So I'm also going to label that on the diagram. So I've now got two base angles in an isosceles triangle. So to work out angle X, let's see what colour we've not used. Let's go to that blue. So I'm going to go X is going to be 180 degrees because it's angles in a triangle, minus QFE, which is 27, and minus QEF, which is also 27. So I'm going to be doing 180 take away 54. And I should therefore get an answer of 126 degrees. Okay, let's flick back to question 7. Now, question 7, there's probably many ways to do it, and I think some of you have probably done it through trial and error. That's absolutely fine. This is quite an advanced question. The other way that we can do it is by setting up a pair of simultaneous equations. Now, this isn't a topic you've necessarily covered just yet, but it's something that we can do. So it says ratio of exterior angles. So the ratio from A to B is 1 to 3. So if the angle here is X for the exterior angle, then the exterior angle on B would be 3X because B is 3 times bigger than A. Okay. Now it comes to interior angles, so I'm going to use a different letter. Now it says the ratio of interior angles is 7 to 6. So I'm actually going to label this angle as 7Y. Okay, I can't use X because I've used that for my exterior angle, so I'm going to put 7Y. And therefore the interior angle, on B, I'm going to label as 6Y. Now I know from my very first slide that an interior angle plus an exterior angle adds up to 180 degrees. So I'm going to write myself two equations. Using shape A, I'm going to write down that I've got X that 7y equals 180 degrees. And using shape B, I also know that 3x plus 6y equals 180 degrees, because an interior plus an exterior add up to 180 degrees. Now, at the moment, those equations, I haven't got anything similar, so it's going to be quite difficult for me to solve. Now, I can manipulate these equations like we do when we're solving any equation. As long as we multiply our entire equation by the same amount, okay, we're not actually going to change the value of our x or our y. So I'm actually going to try now and multiply equation 1 by 3. So I'm going to multiply that top equation there by 3. So if I rewrite that now, I'm going to rewrite it in red. So I'm going to get 3x plus 21y equals 540. So I've not changed that equation because I've multiplied the entire equation by it. Okay, now I'm looking at my second equation. I'm thinking, well, actually, that's got a 3x in it. So what I've now got, and you can see I'm rewriting equation 2 from shape B, I've now got a similar number of x's. So what I'm actually looking at now is, what's the only thing that's different between these two equations? Well, the answer is the number of y's. So what I'm going to do is I'm going to take away these two equations. Okay? So if I take these two equations away, my x's, they're eliminated because 3x take away 3x is 0. 21y take away 6y is 15y. And 540 take away 180 is 360. And now, all of a sudden, I've got this really nice equation that I can solve. So to find out 1y, I could do 360 divide by 15. And I get y is equal to 24. Okay, well, that's helpful, but I still don't know what x is. And x is really key because x represents my exterior angle. And I can find the number of sides on any shape nice and easily if I know that exterior angle. So the next thing I'm going to do is I'm going to substitute my value for y into one of my first equations. So I'm going to use my equation at the top that I've just put an asterisk next to. So I know that x plus 7y equals 180. Well, I now know that y is 24. So I'm going to do x plus 7 lots of 24, which is 168. And that's equal to 180. So for me to now find out what x is, I can do 180, take away 168, which is 12 degrees. So I now know if I go to my shape A, that x is 12 degrees. So now comes the most important part, where we now look at finding the number of sides, because that's what it wants in the question. So our number of sides, if we remember back to our first slide, number of sides is 360 degrees divided by our exterior angle. So our exterior angle is 12. And I now get an answer, 360 divided by 12 is 30 sides. So there's 30 sides on polygon A. Okay, but as I said, that's probably the most difficult question there. And obviously we're touching on some simultaneous equations that you've not yet covered. But it's still an accessible question for you all to at least have a go at and try and get some marks on.